Challenge in the transformation or transition to clean energy has been mostly related to the convenience and obviously its cost as well. And the way to bring convenience in the transition to many of the vehicles that today are electric is to actually offer the same experience that they have with conventional diesel and petrol power cars, essentially charging or refueling in the same time. So that paradigm is something that we're able to offer with our batteries. We can charge our batteries fully in under 6 minutes, and we've done this with a combination of new materials, new cell designs, new systems integration, new software behind the whole technology stack to be able to offer a full solution that gives you an end-to-end fast charging capability to power everything from cordless devices all the way through to electric vehicles, one which you're seeing right behind us. So our battery technology is based on an advanced lithium-ion technology. So this advanced lithium-ion essentially uses existing cathode materials, existing electrolytes, existing cell components, but we've redesigned the cell to be able to accept a high input power, and also it's designed with an ultra-low impedance. So you have different types of advanced anode materials that either improve the power capability, and that's where we've been focused mainly on, or people have been focused on the energy density capability, and that is in the direction of lithium metal or additional silicon inside the anode and things like that. And on the cathode side, we've seen higher nickel, reduction of cobalt as a general trend, but there's also a transition to even higher energy systems where there could be air cathodes or sulfur and materials like that. And on the electrolyte side, we've seen everything from solid to semi-solid. All of these technologies have their shortcomings at this moment because the incumbent is lithium-ion, and there's so much momentum behind lithium-ion that it will stay for a very long time. And different parts of the industry, as they electrify or the grid decarbonizes, will need different types of batteries, and that's established not now, but established more than 100 years ago, where different types of batteries that were invented have still played a role. Alkaline batteries are still used in the industry in large volumes. Lithium-ion has not displaced it. So I believe lithium-ion will stay in places that it works best, and as new technologies come online, then they'll start finding new applications, and generally that's how the industry's evolved. And the transition to new technologies takes time, and you have to really prove it out in every level in the value chain, which is why what we've been looking at is this entire systems level approach with a new chemistry. And it is an advanced form of lithium-ion, but it is proven at the cell level, proven at the materials level, and also we've shown that it can be done at the systems level and integrate that into a full vehicle. And what we've done recently, the car that you see behind me, is essentially a combination of all of those technologies when they come together to really offer a full charge in under 6 minutes. And we've done that, and now it's ready to be adopted in the wider world. Cell side of things, we've been already producing tens of thousands for some time now, so it's given us confidence that we can go a step up in scale. So what is needed is to move from the megawatt hour level to the gigawatt hour level to really bring the cost down and get it into a bigger segment of the market, or multiple segments in the marketplace. So that's where we're headed. Yes, we will be looking at a Series C sometime in the next year or so, and very excited about that.